Okay, so I'm sorry about the technical difficulties. I wish I really could do something about that. But this is the best I can do. So I'm just going to post the last two examples from the notes. And remember, we're just practicing using the slope formula. Slope is just a measure of the steepness of the line. And the sign of the answer of the slope also tells us whether the line is increasing or decreasing from left to right. So what I do when I'm given the 2 points on the line is in the formula, these variables with the subscripts refer to the x and y coordinates of each of the 2 points. So the first thing I usually do is label the first point x, y with the subscripts 1, so x1, y1. And then the second point would be x2, y2. Of course, the x coordinates are always the first number in the ordered pair, and the y coordinates are always the second. So when I go to substitute in, be careful if the coordinates are negative, because we're keeping this as a subtraction sign is separate from the negatives. So y2 is the number -2, and then I'm going to subtract, that's the subtraction sign from here, y1, which is a 5. And then in the denominator, x2, the x coordinate of the second point was 1, and then the subtraction sign, and then x1 happens to be a -2. So I put that in parentheses so that I know that this is 1 subtract -2. And then I just do the subtractions. So remember the whole same change opposite. You can use same change opposite here, or you can kind of just, you could use calculator, but you could also kind of mentally figure out what it would be. So if it was -2 subtract 5, that would be like -2 plus -5, right? Same change opposite. So that would be -7. And then in the denominator, 1 minus -2. If I did the same change opposite, that would become 1 plus +2. So 1 plus 2 would be 3. So generally, remember we said that we wanted the slope to be a fraction. We don't want to change it to a mixed number because we talked about how the slope was the change in the y direction over the change in the x direction. So visually, I want to be able to see like how much is this line changing in the y direction and how much is it changing in the x direction. So I do know for sure that since it's a negative divided by a positive, this is a negative slope. The answer is negative, and that means this line is going down, right? And then I'm going to leave it as 7/3. I can't simplify that. I don't want to change it to a decimal because remember, I want to keep those two pieces so I can look at them and know that this line is going down 7/3. And then the last example in your notes looks like this. Find the slope of the line that goes to the points -2, 1, and 3, -9. So slope, remember our slope formula, m equals, it is the change in y, that delta y over delta x, but when I'm finding the change in a number, I'm going to subtract the y coordinates to get that. So the formula is y2 minus y1 over x2 minus x1. So I'm substituting in 4 values, and the 4 values are coming from the 2 points that are on the line. This is x1, y1. This is x2, y2. Now, some people say, well, what if you call this one x1, y1, and this one x2, y2? It wouldn't actually matter. All right, so if I had subtracted in the opposite order for this last question, the only difference is, think about what happens if you were to do 5 minus 2, I just made up a problem, that would be 3, but if you were to do 2 minus 5, that would be -3. So what happens is if you were to subtract them both in the opposite order, instead of getting a -7 over a +3, I would have gotten a +7 over a -3. But end of the day, isn't a positive divided by a negative still going to give you a -7/3? So it really does not matter which point you call the first point and which one you call the second point. What matters is the order that you're subtracting in is consistent. So here, if I go back to substituting in, y2 is -9, the way that I labeled them. Then there's a subtraction sign. And then y1 is a +1. And then down here, x2 is 3. And then there's a subtraction sign. And then x1 is a -2. So I am going to put that inside of parentheses. All right, if you want to use those boxes like I did in the first example in class to kind of open up those 4 spaces, then the box kind of serves as the parentheses. All right, so then just do the subtraction. Use same, change, opposite if you need to. So -9, take away one more, you probably know is -10, or you could do same, change, opposite. And -9 plus -1 is -10. And then 3 minus -2 becomes 3 plus +2, and 3 plus 2 is 5. So it's a negative divided by a positive. So again, this is a negative. And 10 divided by 5 is 2. So it would not be wrong to say that the slope of the line that goes through those 2 points is -2. We'll see why I like to call it -2 over 1, so that I can see the change in y and what the change in x is.